XXX! Triple X!
Greetings, everybody. Thanks for joining me again. Today we're going to be just doing kind of an overview video of a repair I did for a buddy. He had a Peavey XXX that kind of crapped out on him on stage and blew the HT fuse, and he didn't really know what to do. I took it in. I found out that it was kind of over biased for what it should be, and then we did an entire cap job on the amp, did a total cleanup and a rehab, and now it's back to sounding exactly how Peavey designed it to be, which is absolutely punishing. This amp is one of the flagship amps from Peavey in the early 2000s with that signature 120 watt power section. It has a 3-channel normal, crunch, and ultra, and can run on 6L6 or EL34s. This one in particular had been switched from 6L6 to EL34s. They did switch the bias switch to switch the types of tubes, but they didn't rebias the tubes themselves. So they were coming in at about 55 volts compared to 42.5. We are going to go into a more in-depth review of the repair and then a sound test at the end. All right, y'all, we're going to be going over what we did in the XXX. So we have these string of diodes here that were replaced. That's the rectifier diodes. That's what turns the DC into AC current. And then we have these capacitors here, these power capacitors, unintentionally all matching pretty much. Got these caps here. And I'm going to show you something about the cement resistors as well. Nice ohmite resistor there. That's a 400 ohm. Some V-shays, these small film caps. Those were replaced as well. Those replaced the old IC mustard caps. And then we have these other power caps here. I'll tell you why I went with the long, tall power caps too. Nice big power cap replacement there. Mustard cap replacements. And then these other power capacitors there. So why did I go with the tall, long power capacitors instead of the short, fat ones that were in there? So as we can see, first of all, if you see IC, the Illinois power caps in your amp, they're mostly in a lot. They're in a lot of amps actually, but mostly in like PV amps. Just replace them, take them out, replace them. They have a history of being bad, but these are nice Chemicons. These are Japanese power capacitors. These are definitely some of the best on the market. High capacity capacitors and long lasting. I mean, some of these last 12,000 hours. I think these tall power capacitors are probably 5,000, I want to say, at temperature, which is 105 Celsius. So operating temperature probably for an amplifier. But why did I go with these long, tall caps? Well, I went with these because if you think about it, power capacitors are heaters, basically. As they take in energy, they are heating slowly. So if you think two large heaters next to each other, like the ones that were sitting there previously, if they're sitting next to each other, and they're touching each other, basically, that's creating all this heat in this little area instead of just isolating it to one small part of the board like it should be, and then having some space in between them for heat dissipation. There's none. So then there's two large power capacitors heating up and therefore playing off each other's heat, increasing both of their heats at the same time and dissipating all of the heat probably on a larger surface of the board. So then that way it's going to burn out quicker than, two of these long ones that have plenty of space, okay, surface area, all right, to for heat dissipation. And then on top of it, there's plenty of cooling opportunities because there's so much space in between each capacitor. They're not playing off each other. They're not heating each other up. They're not two heaters standing next to each other, using each as a heat sink and then slowly causing each other to fail. So that's what I mainly did for the that's why I mainly went with the tall long capacitors and with some RTV on there. As you can see, some silicone RTV. these aren't going anywhere. As long as the amp is taken care of, which the owner does take care of his amps, these power caps aren't going anywhere for a long time. And then these resistors, these cement resistors, these were burnt out completely. This is the old one. These are some Dale or CBS ones, 50 ohm. And as you can see, they're just, as you can kind of see, this one is just basically garbage. These are flame proof resistors. So if these burnt out like this, to the point where, you know, the leg is charred and it's black, and they pretty much, I didn't even have to really snap through them. I kind of pulled it and it just kind of released. These have to be replaced for sure. I mean, if these don't get replaced and they short, it'll damage your amp and possibly set it on fire. I mean, like I said, these are flame retardant, flame proof basically. I have put inadequate resistors in the spot that they should be, and in the spot where, you know, cement resistors should be, and they lit up like Christmas trees. They completely burnt out within 5 seconds. And it will definitely start a fire, definitely blow up your amplifier. But you know, experimentation is important here. So yeah, that was pretty much it on the board. Everything powered up great. We're just gonna bias it up to the Peavey spec 42.5 volts for EL34s, and then button it all up and get it back to the owner. All right, this is just a picture of some of the IC caps that were replaced. As you can see, they were mostly Illinois caps. And shout out to Dr. Ross Sewage from Exhumed. He's the one who gave me that bias voltage. I could not find it in Peavey's manual. And here's a picture of the XXX. It is buttoned up, cleaned up, and back to the owner, and he's absolutely loving it. Here's the sound test.